Good afternoon, everyone. My name is John Brkopac, and welcome to my presentation. Back in 1995, I was introduced to a very cool new technology called Essbase. In those days, the spreadsheet of choice was Lotus 123. The word processor of choice was WordPerfect. You may remember those products. Anyway, my role was as a pre-sales consultant, and I helped our salespeople really help prospective customers understand what this brand new multi-dimensional database technology was really all about and what it could do to help them solve their business problems, specifically in the area of budgeting, planning, and forecasting. It's hard to believe. It's 25 years later, and I'm still extolling the virtues of this incredible technology, how its creation has spawned absolutely tens, maybe even hundreds of millions of cubes, and how it's been adopted by many of the largest companies in the world. As I was going through my archive, I actually found a copy of Essbase 4.0 in the package. Some of you may remember that as well. Kind of dates us if we do, a long time ago, but still an amazing, amazing technology. All right, so let me introduce you to the client. $15 billion telecom with 15 million subscriber connections. So their main business lines being cellular wireless, internet, cable TV subscriptions, and of course their legacy landline business. Specifically, our client for this particular project was the Customer Solutions Delivery or CSD organization, and they're responsible for services such as installations, repairs, relocations, etc. And they need to manage and deliver those services, including staffing and delivery of the services. Now, they had, I guess, what one would call a classic business problem. And that was on one side of the scale. They had the demand for their services. And on the other side of the scale, they had the supply of skilled resources that would deliver those services. So the problem is, how does management both optimize and forecast the supply and the demand for those services? Now, demand can be generated organically through existing customers, and there can be created demand through marketing programs or promotions. On the other side of the scale, the supply comprises both in-house resources, those would be employees, as well as skilled contractors. All right, so of course, the desired outcome is that the demand for services is covered by the supply of services and the supply of resources that are available. Too much demand, customers wait, and business is potentially lost to competitors. Too little demand, and employees and contractors sit idly with no work. So optimizing the demand and supply ultimately produces profitability, the cornerstone for any business. All right, so where did we start? It may not surprise you that the customer was using Excel. You may have heard of it. As for myself, I also use Excel, but recently we haven't been getting along. Yeah, unfortunately, we don't have the same values. Anyway, compounding the Excel problem was that there were two disparate management teams responsible for forecasting. One was located in Vancouver, British Columbia, and the other one in Calgary, Alberta. And because the system was managed manually, there was a lot of emailing of Excel spreadsheets, reports, as well as the validation of the numbers across these two management teams. So in speaking to the client, these were the key issues that they were facing in their Excel-based system. And if you've used Excel, especially in your business, these may seem very, very familiar to you. Processes for the customer, just the loading, the input, and the validation of data was time-consuming and absolutely horribly tedious. They used Excel-based formulas, of course, and that meant millions of cells to manage, and that translated into very, very long calculation times. These elements meant that there was really a low confidence in the numbers, creating a fair bit of anxiety every month in the management team. Also, the specter of system crashes was always looming, heightening that anxiety and further elevating it. Now, the limited amount of levels of data that they were constrained to because of the Excel technology and their limited ability to perform scenario analysis really created forecasts that were crude and consistently inaccurate. Finally, because of the multiple spreadsheets that comprise a system, reporting was inconsistent and led to time wasted over arguing who had the right numbers. Those for our customer were the key issues, and of course, et cetera, there were many more. Now, on a separate but related note, a little bit of fun fact is that master forecaster Sylvia Brown was born on this day, October 19th in 1936. She would have been 84 today. So in 1997, I eventually joined Arbor Software, which was the original developer of Essbase, also as a pre-sales consultant. And then following the 1999 merger, which created Hyperion Solutions, I managed the West pre-sales team for 5 years. And then after that, moved on to product marketing. So my product was Essbase, and I traveled throughout North and South America, sharing the many successes of Essbase as an enabling technology for business. Following the Oracle acquisition of Hyperion in 2007, my focus was on educating Oracle customers on the absolute epicness of the Essbase technology, and that kind of led us to our client and why Essbase for them to solve this business problem. Specifically, the capabilities that we were espousing as being really inherent to the Essbase technology resonated very much with our client. First of all, an enterprise scale database that manages the data, manages the model definition, manages the calculations, and also manages security. Because it can handle large volumes of data, it was able to, and it is able to operate very quickly without grinding for hours or without crashing. The high-powered calculation engine was designed specifically to have a central repository of rules, and those rules are managed and tested as well as tweaked through this central calculation engine repository. The ability to handle significant levels of detail was certainly important to the client, and that's something that Essbase handles extremely well as its ability to perform sensitivity analysis, also called, what if modeling. And really the key element here is not only its ability, but its ability to then store multiple versions of these what if analyses and then be able to stack and compare those what ifs. Finally, a suite of reporting tools that include the capability of using Excel as a viewer into this enterprise scale database, really allowing for what we called one version of the truth, or one set of data that was available to multiple users and available in real time. These are the kind of capabilities that sold the project to the customer and really were delivered. So as our architect worked together with the client, what he determined was that there were really 3 Essbase Cubes, and using this terminology of a cube really differentiated the Essbase technology from Excel or even relational technology, which was flat or two-dimensional. And the models that we determined after talking to the customer, working through their business processes, and understanding what they needed was that the design really comprised 3 different models in the application. One was the demand model, one was the supply model, and the third one was the employee model. And what was really cool about this and really useful was that these models could operate both independently and work together. So let's take a look at and an overview of the elements of the application and its 3 models. As I mentioned previously, modeling a business in 2 dimensions or maybe even pushing Excel to 3 is really tough. Now you can think of dimensions as really rows or columns, like an axis in a spreadsheet model. So there are, in this application and in the models, 6 common dimensions that comprise the models, and then there are other dimensions which are specific to that particular model. So let's walk through them, and I'll explain to you what these dimensions are. And on the right-hand side in brackets, you can see how many of for each of these dimensions, how many what we call members are contained in each one of these dimensions. So let's start with measures. Now, measures are really the, I guess you could think about them as the accounts or perhaps the metrics that are being measured in the model. And for this particular model, 2 of the key measures, as you might think about this application, would be job volume and the supply hours. In this model, 550 measures comprise that dimension. Now, the year dimension are the actual years that are being tracked. In this particular model, they started at FY13 in order to have historical data, in order to be able to track trends, seasonality, and so forth. And the model currently is out to FY23. The periods represent the months in the model. So we have the 12 months, 4 quarters, the aggregate year, and so forth. The scenarios are what stores the actual data, the multiple numbers of monthly forecasts that have been created throughout the years. And those are able to be stored historically so that the planners can really gauge how well the model is forecasting, and also be able to then tweak the model so that the forecast has become and becomes more and more accurate over time. The versions are things like the working version or versions, the drafts, and the final version. And these are also able to be stored and stacked and then reported on. The key for this model to work was location. Now, they have a business that spans across a very large geography. And so as we go through, and we'll talk about this dimension in some more detail very soon, there are 4,000 members that are part of and make up this dimension. Now, for the demand model, business unit, there were 7 business units, and they apply to kind of a specific way that the business is organized. Products, I think, very self-explanatory. Now, the products are broken down into what they call technology types, and their aggregates. Segment, 3 segments are made up of the consumer part of their business, the business or commercial part of the business and the aggregate, and then the job type refers to things like installations, repairs, service changes, relocations, and so forth. So that is the demand model. As we go over to the supply model, we have the 6 common dimensions. We also have business unit, and then there's an additional dimension that's required for this particular model, and that's what they call resource. And that's where they identify the internal resources and the external resources, which comprise different types of contractors. And that is so that they can then identify where the supply of these resources is coming from. Then finally, the employee model, again, the 6 common dimensions, also includes the employees, and that would be the actual individual service people that provide the service. Now, in this model, we have 25,000 of those, which also include either terminated employees or terminated contractors, because we want to retain the history. They want to retain the history of what happened with those people over the course of time. It's a very large dimension, and the way that it's organized is it's in a hierarchy based on their management structure. Finally, position class, and the position class talks very much to those skill categories that are important, because the skill categories indicate the types of employees based on whether they're particularly skilled at installing fiber, especially fiber, because that's really an emerging part of this customer's business. So I mentioned the location hierarchy is extremely important. Now, the new application, the Essbase application, added a level of detail that was previously unavailable to the business. And I have some notes on the numbers here. So the 70 regions that were originally modeled in the business were in British Columbia and Alberta. So this is kind of our first iteration of the models. As you can see in the green, The leftmost province, British Columbia, the second one, Alberta, was where we started, then grew into Western Canada, which included Saskatchewan and Manitoba, and then ultimately throughout Canada. Now, the 70 regions in BC and Alberta were broken down into 350, ultimately, booking districts. And now with the new Essbase model, this was further broken down into 800 service areas. Now, this allowed CSD to gain visibility into the business operations at really a level that they've never been able to model the business previously. And that was because it was just impossible with the spreadsheet due to data volumes and the complex intersections that were associated with the 800 locations. Now, being able to see this forecast at the multiple layers of granularity allowed for targeted discussion with other company departments, such as marketing, which are marketing at the service level, and field operators, which view supply at a booking district level. So capabilities that they'd never had before in being able to analyze and manage their business. The model allows for each forecast to be seen at each level, and that facilitated collaboration and better decision-making within the group itself. Now, this means, there's one other thing that I think is really, really key here, and this is that they were able to, what they called, layer their business. And the layering meant that because there was both a baseline demand, let's say for the demand model, and also the supply, there was also new demand that was created, as I mentioned earlier in the presentation, through promotions and marketing programs, and the supply, which was able to be elastic or expand based on the number of contractors that they were using in the business. And so what this new capability was able to do was have them break out this baseline demand and then the new demand that was being created through the promotions and marketings, so that they can see them both separately and in aggregate. So this layering was, again, something that it was extremely difficult for them to do in the model that they had in Excel. So this allowed for forecasting of anticipated additional workload separate from their, I guess, the historical demand generated from their existing customer base. To further go into how these models were constructed, let's take a look at the key, what we call artifacts, or those pieces of the model which actually ran and allowed the users to interact with the model. First of all, we have the business rules. Now, those are the calculations that drive the model. Because the rules are model-based and centrally defined and managed, unlike the millions of Excel formulas that needed to be created and somehow managed, we have this central repository of model-based rules in Essbase. As you can see, this was able to be shrunk down to, in the demand model, just 40 rules. In the supply model, 30, and in the employee model, 15 rules. Forms is a way that we create what you might think about as templates. And those templates allow for things like data entry and very quick looks at the and queries at the data. In demand 30, 35 in supply, and 7 of these forms in the employee model. Tasks. Tasks is something that you might want to think about as the business processes that are the discrete business processes which really run the model and have been predefined in the system. We're able to identify those with the customer and then create these tasks so that the managers could walk through each of the forecasting processes and do those in a particular manner that would get them to the final outcome. And finally, what I've labeled here is ODI. ODI stands for the Oracle Data Integrator. And that is the tool that we use. It's an enterprise scale data integration tool. And it's a tool that we use to define how both the metadata and the data was to be loaded from their various source systems. Finally, to give you a sense of the size of the databases, the size of the demand model, about 250 gigabytes, supply 4 gigabytes, and the employee model sits right now at about 5 gig. So as we spoke to to our client, really the spreadsheets that were required to manage the old system had grown to a scale that was completely unmanageable, and really tens of millions of data points. They were being managed manually and had become unsupportable. The calculation times have been problematic, sometimes taking many hours. And something they said, there's significant tribal knowledge that had been incorporated into the spreadsheets over many years had become really, really difficult to leverage. So the new system provided this centralized approach to model structures, to the business rules, and security that just doesn't exist in the spreadsheet world. This makes the model easy to maintain. This made it sure that the data was kept in integrity, and that calculations also were kept in integrity. Now, we spoke about the importance of that location hierarchy earlier in the presentation. The new application added this really important layer of detail that was previously unavailable to the business, and accommodated this layering that we talked about of baseline demand and new demand. It also included, and it was specifically important to them, that they could break out and layer their fiber business, and that's really the growth area in their business. Now, as with the IRR installation and repairs demand and supply numbers, the new demand and its requisite supply for skilled resources that knew how to install fiber, both separately and aggregate, was not possible in the spreadsheet world. So planners can now identify where the fiber demand is coming from, and then be able to place those scarce resources accordingly. Now, because the model operates at a location level, geographical availability is so important, because these resources, they live in particular in specific locations. They can more tightly identify and efficiently deploy those resources. The time time that is necessary to calculate the model results and perform analysis significantly reduced. I'm going to talk about this more on my next slide. And rather than kind of mailing Excel files and PowerPoint presentations, they were able to use the standardized reporting and really get to what we call, one version of the truth. Because the data is stored within a centralized database, the reporting is on one set of numbers. It's in real time. And then the reports and the data and charts and everything represented are available, always current data, and accessible at what we used to call, and we still do, accessible at the speed of thought. So what was the real business wow for the customer? Well, it was definitely the reduction in model cycle time. So let's take a look at what they thought was the most important return on investment in deploying these models. And that was in the monthly demand forecast process. Their monthly demand forecast process typically was a 2 to 3 week process. So if you think about that, at least half, if not more, of each month was being used to load data, input data, validate data, figure out why data wasn't calculating properly. That process is now at 4 hours. They used to only be able to forecast 3 years out. They've now got the model to be able to forecast out at 4 years. And what we started out as being, first of all, BC and Alberta, then the Western Canada region, is now all of Canada's operations that are incorporated into this model. And what this really leads to is both quality management and quality of life. Their business analysts are truly analyzing and improving the business rather than being glorified data entry and validation resources. No longer are there just countless thankless hours of data input and validation. I did recently call and speak to the manager of our client just to touch base and see how things were 5 years out. And there's 3 things that he was really excited to share with me about how things had developed with the application. First of all, the system within the organization was now deemed as mission critical. That meant that IT was responsible for keeping it up, keeping it running, keeping it tuned, doing all of the corporate IT processes around the model, such as backup, recovery, defragmentation. And this is only being done with those applications that are mission critical to the organization. Secondly, he let me know that the application had been fully integrated into their business. Now, what that meant is that all managers across the country depend on this application to run the business. There are no shadow systems, no other side spreadsheets that are helping to calculate. This truly helps them run the business. And then finally, they've continued to expand and grow. New capabilities are continually being added to the systems, and finer level of detail is being added as required. So what were the success factors? And I think it's important, again, as I discuss this with the client, I really wanted to know, because we're a sales organization, what worked for them, and what really were the things that made this project successful. And I think it's really what's typical of the way that we work with all of our clients. First thing, never ever oversell a project. Making wild promises. And I know Essbase is incredible, and we've done some just magnificent things with the technology. But if you oversell the project and make these kind of wild promises about what the technology and implementation can deliver, it just doesn't ring true with the client. They're looking to solve a business problem, and promising too much just comes across as unbelievable. Our customer understood that a manageable project typically translated into a successful project. Secondly, our architect worked with the client to understand their business processes at a very detailed level and where the key pain points were. He built trust, he built relationship, and the customer developed faith in his ability. We surrounded him with an experienced implementation team that delivered on the design. And finally, the customer's team, well, they were highly motivated. After all, they had been living in Excel hell for years, and they worked closely with our architect as he dove into their business process and then crafted the system design. Okay, so that's really an overview of this supply-demand optimization and forecasting model. And now that we're coming to the end of the presentation, I've just got a few minutes left. I'd really like to talk about, why BluMarble? And should you be considering an implementation partner or require assistance with your existing application? So here are the things that BluMarble brings to the table. First and foremost, we have a track record of delivering for our customers. Our references are impeccable. We're focused on the leading EPM implementation technology, and that is Oracle. We're not wasting our energy defocusing our resources on jumping on and just defocusing their attention on the technology du jour. As we work with our customers, we built an EPM specific project methodology, and we now employ that in every single one of our projects. In addition, we've also developed a comprehensive set of documentation templates that are a core deliverable for every one of our implementation projects. Now, with the initial promise quite a few years ago of offshore remote application development, and then now the emergence of COVID, customers may buy into significant remote application development. Now, while we believe that there is a place for remote development, we also believe that there must be relationship and trust built between the project team, the customer team, and our architect and our development team. This is especially important with the architect so that all aspects and nuances of the business and their business processes are properly reflected in the design. Now, all projects have tough moments. We know that, having delivered projects, and we think it's so important that as we work through these projects that we've gone through a transparent contracting process with the client. We've done a detailed review of all project phases, the resources that we're going to deploy, and the deliverables that the client can expect. We despise this kind of lowball and change request tactic that many services organizations employ. Now, adopting a new technology is a great time to be able to assess your business processes. We don't believe in this kind of technical implementation, simply taking what you have and then dropping it into and deploying it into a new technology. We think that's a real waste of a great opportunity. And then finally, we offer other related services such as mentoring, administrator training, staff augmentation, and budget cycle support to customers that would require this kind of short-term help. So if you would like to learn more about us and our services, here's our contact information. I truly appreciate your attendance this afternoon to my presentation. If you are watching this as a recorded presentation, also thank you for taking the time to review the presentation. If you want to discuss this particular project further, I'm happy to introduce you to the client and have you speak to them directly. If you aren't a telco, but have this supply demand issue, I mean, this is true of any organization which is marketing services and then also has a limited supply of skilled resources to meet that demand. We'd certainly like to talk to you about how we can help. Our website, currently under construction, will be available in the next couple of weeks so that you can look us up there. I'd like to wish you a great day. And if there are any questions, be happy to answer those right now. And I think we have just a couple of minutes left in my time.
Great, thank you, John. If anybody has any questions, we'll stay on for a couple minutes if you want to pop them into the Q&A box.
Okay, well, I guess I explained this with such clarity that that there are no questions, or we can certainly take questions offline if somebody wants to speak one-on-one.
Yeah, or they can email you. I believe you gave out your email address, so if you have questions, you can just email him. Sound good?
Sounds great.
Okay, well, thank you so much, John, and thank you everyone for attending. We hope you had a great session and have a good evening.